So I'm going to talk about the optimized pad well placement workflow that I've come up with using ArcGIS, Openspirit, and Petrel. And if anybody has questions or comments while I'm in the middle of talking, just go ahead and interrupt me. I prefer it that way. So I'm sure that it's pretty common for most oil and gas companies to want to optimize pad construction sites and how they're going to lay out their wells. I started working in petroleum about 7 years ago. From the very beginning, I was interested in GIS solutions for optimizing drilling locations. And a lot of these ideas came from being an archaeologist for 13 years, predicting where archaeological sites might occur. So a lot of these ideas came from that. Every year, Range Resources does an LRP, which is our long-range plan, and that's basically, we try to figure out ultimately how many wells and pads we can build given our leaseholds and the geology that's associated with that. That's all done, well, prior to this, it was all done manually by hand. Our GIS department maybe had 5 people who would sit there looking at maps and just using their own biases would try to lay out as many well legs as they could over our lease area. So about 3 years ago, I wanted to try to, apply an automated process to this, and so I got together with Petrel to see if we could come up with a plugin that would allow me to do this. And the goal of that was to combine my previous GIS analysis methodology with some sort of subsurface constraints that would take the entire picture into consideration instead of just doing this at the surface. It wasn't until that collaboration resulted in what I'm talking about today. They came out with 2 plugins. I wanted 1 plugin, but I got 2 instead. I'll talk about that.
2 for the price of 5. Right?
Yeah, something like that. So it wasn't until I started using Petrel that I figured out it really isn't much of a GIS system. It's not very user-friendly. I struggled to get spatial data into it from multiple places. It's not an intuitive workflow to regular GIS people like you guys. And it lacks a lot of the functionality that you might find in ArcGIS. I think it was maybe 2012, I went to the Esri Pug and just by chance came across a presentation that was titled something like getting shapefiles into Petrel. And I thought, oh, that was great. So I went in to that presentation and learned about TIBCO's Openspirit, and that was pretty much the final, that was the key to the workflow that I was looking for that I'm presenting today. So this is it, and it's real simple. Everything starts in ArcGIS. TIBCO, the Openspirit, was the missing key that took care of a lot of the transfer issues that I was having, and that allows me to transfer everything pretty much seamlessly into Petrel. So in addition to of course you need ArcGIS and you need Petrel, but in addition to that, you need these 3 other pieces of software from Openspirit. You need the plugin for ArcGIS, you need the plugin for Petrel, and you need the runtime to put the whole thing together. Openspirit was originally created actually for the oil and gas industry to transfer data sets between all kinds of G&G software products. This is the model that I'm using. I'm not going to go into the detail of the model, but it's pretty basic. It's just it's taking all the surface attributes and restrictions that we might want to look at, putting them all through all my geoprocessing tools. The important thing here is the output is the final optimized layer that I use to transfer into Petrel. So this is just the surface analysis that I was talking about earlier. And you can obviously add any number of attributes to this that you want to add. So once that is created, I can transfer that information straight into Petrel. And it's real simple once you, well, installing Openspirit was not simple. It took a lot of coordination with IT departments, but once you get it working, it's you have taskbars in ArcGIS and a taskbar in Petrel, and any other software that you have Openspirit installed for, once they're all activated, they're now listening to each other and they can all talk to each other. So it's just a simple matter of pushing the icon in ArcGIS, selecting the information that you want, hitting an icon, and it transfers it to Petrel. And it just takes a couple seconds. Once it's in Petrel, then it's a Petrel layer. It's no longer related to anything in ArcGIS. So if you start doing stuff to this layer in Petrel, it's completely separate from ArcGIS. And once it's in Petrel, it goes, like I said, there are two plugins. There's the pad placement plugin and the pad well design plugin. I wanted one plugin, but they were sort of putting this together from previously created plugins that they had. And it creates some confusion in the process. I'll talk about that in a minute. But that's the workflow once you get it in. And from here on out, all the analysis that I do is done in Petrel. So this is the first plugin that you use. It's the pad placement plugin. And over here is, these are all the layers that you insert into the plugin. And for each layer, you identify whether it's a layer at the ground level or a layer at the reservoir level. And for each one of these layers, you set up what's called a cost function, which I'll talk about in a second. And that's Petrel's version of buffering. This slide is a little misleading because just for visual purposes, I have all these layers put in here. But in my workflow, all the surface analysis, all the layers here that would relate to the ground level, I've already done the analysis in the ArcGIS model. And so usually when I do this analysis, the only thing that's over here is the layer from the ArcGIS surface analysis and any other layers that might pertain to the reservoir layer. So you can do that surface analysis here, but the processing time is really painful. Yep.
That reservoir, is that subsurface? Is that what that means?
Yeah, that's what they mean. You'll find that a lot of the terminology in these plugins is really strange, and I really think that's because it was designed by reservoir engineers, and they're not GIS people. So back to this cost function thing. This is I've had so many arguments with Petrel about this. I still don't really understand it, but I'll explain it the way I think it works. They're basically, instead of looking at buffering as how far can you be from something, they were looking at it as how much will it cost, because they wanted to put an economic aspect into this whole process. I didn't suggest that. They just kind of put that in there themselves, and so then it confused the whole concept of the buffers and the restrictions. And basically what this is saying, it happens to be in meters. This is a streams layer, and it's saying that as long as you're within this range, 60 meters to whatever I put in there, 100 million meters, as long as you're within that range from a stream, there's going to be no cost. And then I guess presumably if you're outside of that range, there is a cost, even though I haven't defined that anywhere. So that's that. The next tab in the plugin is the pad selection tab. Each one of these is a pad configuration. You're looking at this one. It's 18 wells, so it's a 9 by 9. So for each one of these pad configurations, you define your maximum and minimum well lengths, your step outs, and the azimuth that you want the wells to be laid in. Each one of these pad configurations can be customized. They're editable individually, or you can apply those parameters to the whole thing. This list is also hierarchical, so in the analysis process, it'll start at the top of the list. It'll run the analysis, and if it can't fit a 9 by 9, given your parameters, it'll move to the next pad configuration. Try to fit that and just keep going down the list. Sorry. Each one of those configurations is created with a customizable XML code. That's how I created the layouts. That's the XML code, and you can see I created something like 45 different layouts that I use in this analysis, and it can make you go blind really quick. Hopefully in some later versions, they're going to have something that's a little easier to construct the pad layouts that you want to use. But for now, you got to go through this code, and it can be pretty tedious. So you enter all those parameters, you run the plugin, and this is the output from the plugin. So the dots are the optimized pads, the locations for the pads, and the lines are the lateral lengths of the wells from the heel to the toe, and those are also optimized. So given your optimized location, given my optimized locations for the surface analysis, it goes through those areas. It chooses where to put the pads based on the pad configurations that I'm using. It picks the most efficient layout, and then it draws the most efficient legs that would go with that pad. Okay, so once that's created, then that output is put into the second plugin, which is the well design plugin. So on this tab, this is where you take the pad locations that you just created. It's basically just a point file. That's input here. You choose your ground surface layer. You choose your reservoir layer. There's some other options down here, and that is the first tab on the well design plugin. The second tab is where you define the 3D well geometries, the kickoffs, the dogleg severities. This part is a little strange because all these were previously defined in the other plugin, and you can override that information here if you wanted to, but I'm not exactly sure why you would want to. I don't know why you would set it up in the first plugin and then suddenly at this point decide to change it. So this is why, to me, having these two plugins to do this process is a little strange. It would make a lot more sense to me if it was just all one interface. You just go from tab to tab. Hopefully they'll change it around. The other tabs are all for the data management and the output and where to put the folders. So you run that plugin, and this is the output from the Pad Well Design plugin, and it has drawn the actual trajectories of the wells based on all those parameters. You're looking at it from the surface, obviously, but it also then does it in 3D. So this is, to me, what is really the powerful thing about this is it's coordinating all those parameters at the surface, and it's coordinating them with all the parameters in the subsurface, and you're getting an entire optimized layout in 3D. That was really the key to what I was looking for to further our long-range plans and make it the process that we're using now. So once you create all that stuff, once you have your final layers, and you use Openspirit, you can take it back to ArcGIS, you can do more analysis. It goes, when I use it, it goes back into ArcGIS because then it gets passed on to the rest of our GIS department or whoever, their little areas that they work, and they can continue doing their further analysis on it. So the benefits of the workflow was, the number one benefit is that it replaced really time-consuming manual editing. It literally turns weeks into days because, as I said earlier, this was all done by hand in the beginning. The workflow science-based, and by that I mean it's measurable. It's being measured. It's being conducted in a GIS world. It's not somebody just eyeballing a map who might be eyeballing it differently than the guy next door. The great thing about it is it's repeatable. It can quickly be modified. Again, if you have 5 different people doing this by hand, if you ask them to do it twice, 2 times in a row, you can pretty much guarantee that the second time's not going to look like the first time. And well, I know from experience that if something changes, if you laid out the long-range plan at 1,000-foot spacing, somebody comes back and says, oh, well, let's look at it at 500-foot spacing, and instead of a maximum of 7,000 foot lengths for the wells, let's make it 10,000 feet. And so now you can take all those maps that you made, put them in a pile, burn them, start the whole process all over again, and take another 4 weeks to produce it. But with this, it's just simply, you go into the plugin, everything's already saved in there, you just change your parameter, rerun it, and you get your new layout. Finally, the model, like I said, any number of restrictions and parameters can be put into that. Usually those restrictions, the restrictions that you might have are most generally going to be surface restrictions. You can have restrictions in the subsurface as well, different geology, but because you're using, that's why I was using ArcGIS Model Builder and ArcGIS to begin with, was because I was putting so many restrictions, so many parameters into that surface analysis. that it was just so much easier to do it in ArcGIS instead of Petrel. So let me take a drink and I'll talk about the problems. Like I said, Petrel's not a GIS system, and that created its own set of problems because it's not a GIS system. It forced me to integrate other softwares with it, and anytime you do that, you guys are all database people, you know, anytime you do that, then there's all kinds of hoops you got to jump through to get stuff to go back and forth between the softwares. So that leads me to the next point, because I'm using it in tandem with ArcGIS. It created the data issues that I haven't gotten into them, but it's an ongoing problem. I don't know if TIBCO, I don't know if Openspirit is changing the data, or if Petrel is changing the data. It's been a process trying to track what is changing and who's changing it, but it's still doable. You just have to jump through those hoops. The plugins are confusing and user GIS unfriendly. Like I said, they were designed by reservoir engineers, and the terminology is all wrong, and just kind of the logic behind it is kind of strange, and the workflow between the two plugins to me is a little strange, but hopefully that's going to change. One big problem that I found out was that it's really not designed for the complexities of Southwest PA. It's our complex leases, the large geographical areas. The large geographical areas cause a processing problem. Processing can take hours. It can take 2 hours, 3 hours. And that's really frustrating, because if it's a trial and error process, and if you have to change one little number, you don't know it until 3 hours later. You run it 3 hours later, it's, oh, I have to change one number, you change one number, and then you gotta wait another 3 hours to see the results. And finally, it's not a one software comprehensive solution, but right now it's the best thing that I've come up with. And I would be curious to know if anybody else is using it. I haven't come across anybody who's using these plugins, but I'd like to know your thoughts on them. So, thanks.